Okay, so we're going to get started. Thank you guys for filling out that survey. I know that the people at large appreciate it. So the other thing that I will warn you all ahead of time, today has been one of those days for me where it appears that everything I touch breaks or falls apart or doesn't work. So whatever I try to do in lecture probably isn't going to work, and it's just going to happen. And so it is what it is, right? So be forewarned. If you ask me for help, I might break it. But hopefully not. So anyway, let's start in on exercise 213. And for exercise 213, essentially we're continuing on where we left off from 212. Most of you should have gotten to the point where you have the steps, and then we'll concentrate on kind of how the corners go together. In the interest of review, I'm going to start at the very beginning and go through the whole process again, recognizing that that'll probably take me 20 minutes to get through it, and then we'll pick up where we left off. So if you feel really comfortable and you want to tune out for 20 minutes, if you feel like you know what you're doing, that's okay with me. But I think it's useful just to have me go through the whole process yet again. This will be the last time that we go through this process. So after today, you're on your own in terms of actually cutting out the model, getting all the pieces ready, that sort of thing. I will cut a sample file and glue it together next week. So that you guys can see how to put it together and kind of the techniques involved in doing it. There is a video online of me putting it together before, so that you can still refer to that. I'll probably try to record it again so that you guys can see that as well. So I'm going to go ahead and start all the way back at the beginning in SketchUp, and I'm going to get a piece of terrain. I'll pick a different piece of terrain than the one that I picked last time. So let's see here. I'm going to go to File, Geolocation. Actually, before I do that, I'm going to get rid of this person. And then I'll go to File, Geolocation, Add Location. And I picked Tahoe last time. I don't know. We'll do Tahoe again. Why not? No, let's do Hawaii. Yosemite. All right. Let's make this a little bit bigger so that I can see a little bit more. And so we're going to avoid things like this, which are never going to really turn out nice. Let's see here. Yeah, we'll try this. We'll try this region, see what it looks like. And I'm going to go to File, Geolocation, Show Terrain. It's a reasonable piece of terrain. It's not too steep. Sure, why not? We'll go with it. Yeah, let's find something a little steeper.
Yeah, go to Hawaii. Very good. Is that in Yosemite?
Yeah, that's in Yosemite. We'll pick something like in about this region. So I have to avoid all of those really steep hills, right? We can't do Half Dome. That's a bad idea. Yeah, maybe it's something like. We'll try that. So geolocation, show terrain, let's have a look. Okay, it's reasonable. This side I feel good about. That maybe is doable. It's a little on the steep side, but I'll go with it for right now. Okay, so I'm going to go back to File, Save As, and I'm going to make sure that I pick a SketchUp 2013 or earlier file. That's what Rhino can see. And I will call this Yosemite. And I'll save it on my flash drive into today's folder. Perfect. So now I have that, and I can go ahead and close SketchUp, and I can start working in Rhino. I have my file from last class already open, so I'll just open a brand new Rhino window. And we'll go New, Large Object, Inches as my template. Remember, it needs to be in inches in order for the terrain to come in at the correct scale. Then I'll go to File, Import, and I'm going to import the Yosemite file right there. And the default options here are just fine, so we'll go ahead and say OK. And if I look, there is my mesh. I'm going to go into shaded mode so we can have a better look at it. There it is. I don't need the flat surface, so I'm going to go ahead and create a new layer. We'll call it SketchUp. And a new sublayer, and we'll call it flat plane.
Would you open up a big square at the bottom?
No, that was existing when I brought in the SketchUp terrain. And we'll do one more for SK terrain. I'm just trying to stay organized here. So we'll put this on this layer. And we'll put this on this layer. I could just delete it, but this way I have the ability to just turn it off. OK, so there's my SketchUp mesh that came in. I need to convert it to the Nurbs object, just like I've been doing. So I'm going to do the contour in the X and the Y. So we'll use a new layer called Contour X. And we'll do another layer called Contour Y. All right, and I'll start from this corner right here, making sure I'm on the Contour X layer, and I'll use the Contour command. It's also under Curve, Curve from Objects, Contour. I'm going to contour the mesh, starting with my vertex snap on in that corner. Again, going off in space just in the X direction. And distance, we'll try 100 feet. Looks pretty good. Remember, I'm not going to repeat the contour with the line selected. I want to go back to the surface. So we'll repeat this now. Curve, Curve from Objects, Contour. Or you can just type contour. I'm going to contour the mesh. This time it will be in the Y direction, so we'll go off here in the Y direction. And I'll go ahead and press Enter because the default value of 100 feet was still there. So now I can turn off the SketchUp layers altogether, and I can look at my curve network in the top view. It is a grid, which is exactly what I was after. I'm going to do a little bit of trimming here. I know that I have way more than I need in terrain, so I can be rather generous with how much I'm cutting off. And I'll do trim. And remember, if I select from the right to the left, everything that I touch will get trimmed off. That was a little too much. There we go. There we go. Always a little trickier on this edge to go from right to left. But that should do it. Perfect. So now I have my curve network. And obviously, I'm going a little faster today. This is the third repetition of this, so I feel like I have the right to go a little bit faster. And so now I have the curves that are going to make up my curve network. And they've been established. Before I actually do the curve network, I am going to save this file. And we'll save it as exercise 213. And I'll click Save. And then I'll go ahead and do the curve network of this object. So I'll go select the objects, go to Surface, Curve Network, or excuse me, Curve Network. Yes, I do want to continue. And this is going to take a few minutes to process here. We'll say OK. And we'll wait. This part I can't speed up. I'll help you.
I got the X and the Y down.
Good. Okay, so it's now finished, but the surface, the resulting surface, is that super dense, slow down your computer style surface. So I'm going to click and attempt to select that surface. It'll select in all yellow. That's how we know it's too dense. And I'm going to type rebuild or go up to edit, rebuild. And I'm going to rebuild the U and the V to be at 100 by 100. I always start at 100 by 100, and then I take a look at the resulting terrain. And I can actually, this should have been on a different layer. Sorry. Change object layer. And now I can turn off the X and the Y's. And so I can have a look at how jagged this surface is. Yeah, it's still a little jagged. In this particular case, it's not too bad because of the nature of the surface itself. But I'm going to rebuild it again at maybe 75 by 75. And again, that's a matter of your own preference. There's not a right or a wrong answer for that. OK, so I've smoothed it out a little bit. And now I need to look at making this into the physical model. So I just made it through exercise 111. We can look and see. 111, 11 minutes. So we went from 40 minutes to 20 minutes last time to 11 minutes this time. So we're speeding up, right? Hopefully you're speeding up too. Fingers crossed. Anyway, so let's continue along here. And now we're going to move into what we did last class as part of exercise 12. So I'll slow down a little bit as I do this just so that we can review. So once again today on your handout, I gave you the, of course I lost the handout so I can't hold it in front of me. Thank you. I gave you the same chart on the bottom of today's handout in case you left yours behind or whatever. It is in the book too, so you can use your cheat sheet. And from here, I need to establish what is the size of my 11 by 17 at whatever the scale is that I'm going to build my model. And so again, if you were in a studio context, they would say you need to build the topo model at 1 to 200 scale or 1 to 100 scale, or there would be some specific requirement. In this class, there isn't a specific requirement, so you can build it in any scale that you want, and it's kind of up to you as to what scale you want to pick. Obviously, you can't pick a scale that's larger than the amount of surface that you have. So the one that seems to fit most people well is the 1 to 200. So if I look at this sheet, and I look at 1 to 200, and I come over at the 11 by 17 size at scale, that would be 3,400 feet by 2,200 feet. So I'm going to go ahead and draw a rectangle that is at 3,400 feet, comma, 2,200 feet. And lo and behold, this seems like it fits rather nicely on my site, so I'm happy. So at this point, I'm going to move it to be in line with my site. It's a little bit hard to tell where it's going to show up on the particular site. So I'll switch my top view into shaded mode so that I can kind of see what I'm looking down on. Right? And I have a rather empty, vacant center of the site, but I have a few hills. So I want to make sure that I include at least part of some of these hills. So let's try to take a look here. Let me move it. I'm going to try to take that piece, and we'll slice through that little hill. That's there. And let's go a little bit further to the edge because I'll get a little topo on that back side. So let me move it again. And I'm kind of doing a combination of my views so that I can try to determine where this falls on the piece of topography. It's always a little hard to determine exactly where that rectangle is. But it's looking pretty good. I think I'll have good results. So I'm going to switch into the top view. And remember, to do this projection, I have to be in the top view. I can't do it in one of the side views or the perspective view. So I'm going to be in the top view with nothing selected. I'll type project, or I'll go to curve from objects, project. It's going to say select curves and points to project. So I'm going to select that rectangle. I'll hit enter. And it says select surfaces or polysurfaces to project onto. There's my polysurface. And I'll go ahead and hit enter again. And so instead of having that flat rectangle that was there before, I now have a rectangle that represents, right, the size, the 11 by 17 scaled size of my piece of terrain, which is right there. So I'll take this piece of terrain, I'll type trim, and I'll get rid of the outside piece of terrain because all that I'm going to be modeling is this piece of terrain. So now that I have that little piece of terrain, it's time to start working with this piece of terrain at scale so that I can create those jogging steps along the side of this piece of terrain. So I'm going to create contours of this, of this surface. Maybe not. I told you, this was how my day was going, right? Forewarned. So there's my surface. I'm going to create contours in the z direction of this piece of terrain that represents my model. But I have to make sure that I do it at the thickness of what I'm going to construct the model out of, the physical model. So I told you last time that if you bought the bookstore cardboard, it's 5/32 of an inch thick. If you pick some other material, you'd have to measure it precisely as to the thickness of that particular material. This same technique would work just as well if you were cutting out, say, plywood. The difference being that you wouldn't be able to cut out with the laser cutter. You'd have to cut it by hand. But the same technique would work no matter what you're doing it with. So I'm going to go ahead and do my contour. I'll go up to curve, curve from objects, contour, or I can type contour. And I'm going to contour this surface. Go ahead and press enter when I'm done. And I'm going to start it down here in the lower corner. So we'll do that. Now, if I'm in the perspective view, I can only pick contours in the x and in the y direction. Well, these contours have to be in the z direction because they're stacking vertically. So I'm going to switch my view so that I can see either the front or the right side. It doesn't matter whether you're working in the front or the right side. You just want to make sure you're going straight up. And I can actually see this in all three of my views. The perspective view shows it going straight up, the front view shows it going straight up, and the right view shows it going straight up. That's what I want. And I'll go ahead and click. Now, at my scale, the 1 to 200, I'll come over to the value for 5/32 of an inch, and it's 31.250 feet. So my distance between contours will be 31.250 feet, and I'll go ahead and hit enter. And so if I look at this in perspective now, I have all of these contours that have been drawn for me. And actually, this is a pretty good one because there's some ups and some downs that we're going to have to solve. So it'll be good for the phase of what we're doing. Let me go ahead and change these objects onto a new layer. And we'll make layer 4 here my cardboard cut, cardboard topo lines, something like that. And we'll turn off the surface itself. I do want to be able to reference the surface because I'm going to have to figure out when a particular step goes up and when a particular step goes down in this lower, flatter part of this setup here. So now that I have that, I'm going to start to work on the steps on the side. And so like I said last class, I really like changing the C-plane and working in a different C-plane because I think that's the easiest really way of dealing with it. And from a skill set long term, you'll benefit from doing it this way. So for today, I'm only going to demonstrate the C-plane method. If you feel more comfortable with the other method by assigning the points and then rotating the points, there's nothing wrong with it. You get to the same place. It's just a matter of comfort. So right now, my C-plane is in world top, and we can see my little grid there representing my world top C-plane. I'm going to go ahead and make that grid a little bit bigger, just so that you guys can see it on the screen better. I'll go to Tools, Options, and I'll select Grid, and maybe it'll be 2000, and go ahead and say OK. And so now we can see that grid in a little bit larger format. So at world top, there it is, flat on the ground. I'm going to reset this C-plane so that it's going along the side here. So I'll click on this little triangle, and I'll go to Set C-plane 3 points. And I'll start by clicking on the first point, or maybe the second point, along the side of this edge. And I'll run the X direction out along this axis. Again, not snapping to anything, just straight out. And I have to set the Z-axis so that it's going straight up. And the only way I'm going to be able to do that is to look at all my views at once, and there it is in the front, the right, and in the perspective view going straight up. So I'll go ahead and click. And now my grid and my workspace essentially is aligned with this edge of my contours, which is exactly what I was trying to do, so that anything I draw, even if I were to draw, say, a line over here, it's going to be in plane with this edge. I can't draw anything flat. So I've switched the drawing plane to be vertical, which is the idea. So let's go ahead and do some steps, and I'll start working on layer 5, and let's rename layer 5 to be steps. If I can't type. What else is new? Steps. And so that's the current layer, and I'll go ahead and start drawing in my steps. So I'll start at the lowest point here, and I'm going to use my snaps. I'm going to make sure perpendicular is on so that I can use my smart tracking with perpendicular, and we'll work our way up this side. Of my contours. Some of the technique here is in what angle do you view this. So here I am, and you can see that this last contour, this circle, doesn't intersect the side that I cut. And this contour here will actually come straight across and meet. If we follow this contour around, right, it ends up being the same level. So they should be at the same point. And then I'll start going down in the opposite direction. Like that. Now, if I look here, this contour is at the same level as this contour. But I've already gone straight across here. So this particular piece actually has to go down, over, and then back up. But I know my contour interval is the 31.250 feet. So I'll type in that as a value, and I'll have it go straight down. So there it is, going straight down. I'll come straight across and then back up. And then I'll go back up to this last point right here using my smart tracking there. And I'm going to actually end by just extending this line off into space. So over the corner. It's possible at this front location that I also need to go down 31.250 feet. And I'll run this line off into space. Ultimately, I'm going to end up intersecting that line as we go forward. So now it's time to move my C-plane to one of the other sides and work my way up one of those sides. So I'll work my way around, and I'll start now at this point. It's much harder to reset the C-plane using 3 points to here without going back to world top first. So I'll go back to set C-plane, world top, to kind of reset back to the defaults. Then I'll go to set C-plane 3 points. We'll snap to that point. I'm going to go off in space this direction. And again, I have to go straight up in the Z. So I'll do that using my front and or my right view. And so now, once again, that grid is shifted 90 degrees from where it was before. So I'll start at this point. And I'll draw my way up the steps. So here I am at the top of that hill. So once again, I'll go straight across. Now I have to go back down to catch the next set of terrain here. So we'll go down and over. Down and over. And when I get to this last point on the side, I need to go down the 31.250 feet and then run it off kind of out into space there. And I'll come back to this first point, and I'm going to do the same thing. So it's going to go down 31.250 feet. But as I come across here, if I run this off into space, like that, we can see that that corner, we didn't emphasize corners last class, but those two lines intersect at the same level, which is exactly what I want to have happen. So now that those two intersect, I can use a trim command, and I can get rid of that, and they meet nicely at a point. If you try to use the trim command and it won't trim, they don't meet up at the same level, which is a problem. So we want to make sure that they end up at the same level. So I've worked my way around that corner. Now I need to work my way down this side. So once again, I'll reset my C-plane to world top, and then I'll go back and say set C-plane 3 points. I'll start at the first point along this side, and we're going to go in that direction and then straight up. There it is, straight up. And I now have a C-plane at 90 degrees to where I just was. And we'll work our way down this side. So I'll start at this first point and start snapping my way down the side. The good news is this is not the most complicated piece of terrain, so you don't have to sit here and watch me do super steep steps. Okay, so here I am, and it looks like, yes, there's a little hole here, but I'm still going to have to make my next step down. So we'll go there, and then we'll keep going. So while it might have looked like those two were on the same level, they in fact were not. And so I get to that last point. I'm going to go down 31.250 feet, and then off into space that direction. And I'll also come back to this level and go off that way. And when I do that, we can see that once again those two intersect. So it's time to do a trim and trim off those two pieces as well. So I've worked my way on 3 sides. We just have the last side here to go. I'm going to go to my set C-plane world top, and then I'll go back to set C-plane 3 points. We'll go in this direction and the Z-axis. There's the Z-axis. All right. So now this one starts to get a little bit tricky because I've got lots of ups and downs depending on where I am along this side. It's a very flat side, so there's going to be some ups and some downs. So we can tell initially that this step goes down, but this line here is at the same level as that one. So I'm going to start at this point, and I'm actually going to go down 31.250 feet, and then I can come across, and we can see that those two intersect. So I can do my trim like that. So now if I were to continue, I'd have to go straight across to this point, and then I'd have to go down again. So I could type in 31.250, or I could use that snap, and I'll come across until I hit this point. There, and I'll go up. Now this is going to go straight across until it hits this curve. And then I'll have to go down again 31.250 feet across until I hit that curve, and then back up. So you can see that this line's very different. It's not steps, it's ups and downs because it's relatively flat as I go across. So there I am, relatively flat, straight across to there. Once again, I'll go down 31.250 feet. I'll go straight across to there, back up, and I'll continue. Now if I did this correctly, those two lines should intersect at this corner, which they do. So I'll type trim, and I'll select these two, enter, and I'll delete those. So I was able to draw across this front, but this obviously looks very different than the stepping sides of the other side. So this was actually a good example to pick in terms of figuring it out. So I'll go back to my set C-plane world top. And what I'm going to do now is I'm going to make sure that the sides are joined. So that piece is separate from this piece. Now I have everything on this side selected, so I'll type join. And I have one joined curve for that side. Let's look at this side. Pretty good except for that. I'll type join. Now those are joined. Let's look here. I need to join to there. Perfect. And now we'll look at the back side, and I need to join there as well. It's also available under Edit Join. Okay, so now I have each of the sides established for me. I could actually turn off the topo lines, and we could see just the sides for a second. And they're reasonably well set up, and I'm confident that the corners meet up nicely, which is how I want. So now what I need to do is I need to draw some vertical lines from each of the corners down such that they're below wherever my lowest point is. And this will represent one of the sides of the model. Let me run over to my office really fast right here and grab the physical model so that I can point it out to you. Okay, so as I look at this physical model, there's always going to be a low point somewhere on the model. And if I'm going to cut out a side, I want to make sure that this low point isn't right on the bottom. I want to have a little bit of space below it, just for stability. And so this can kind of help the overall model if you have, an inch or so of space below. So it doesn't matter what the value is that you choose to put here. The point is that I'm going to start in this corner, and I'm going to go down some value that seems like a reasonable distance. So something like that seems reasonable to me. I didn't even measure it. But now I can come across, out into space, something like that. And I'm starting to establish what one side of this would look like. So I'll go ahead and come down to there. I used my perpendicular snap. And let me go ahead and trim this off. Oops. Trim. There. And then I'm going to join. So now I have the first side. If I were to take, somehow it didn't like to join here. Let's try that one more time. So I have this side and that top, and that's one piece. I'm going to repeat this for each of the pieces. So I'll go down again with a polyline to here, there, and then off into space, and then straight down, perpendicular snap. So I'm not adjusting the C-plane anymore. I'm just using my snaps. So I'll go to trim, and I'll get rid of this. And then I'm going to take this, and I'll join that together. I could actually take it one step further and take that piece and join it to this top piece. So I now have a whole side. Likewise, I could take this piece and join those. And so I have this side, this side. I'll keep working my way around. Obviously, the bottom has to maintain the same, flat, the same level as I work my way around. So let's go from this corner straight down to perpendicular. Trim. Oops. Trim. There. Join. And let's join it to this as well. Join. Perfect. So I have that. And then I have this one last piece. Notice that I'm not just drawing a line across at the bottom. I'm still creating each one of these legs that go down, over, back up. I'll take that and this, and I'll join those together. Right? So essentially, I'm mapping out where the extents of this particular surface is, this particular stepping side of my topo would be. So now I need those sides to fold flat. And it doesn't matter whether you fold them in or whether you fold them out. You just have to fold them all in the same direction. So I'm going to use Rotate 3D, Transform, Rotate 3D. And I'm going to fold each of these sides out independently. So my axis of rotation will always be along the bottom of each side. And so I'll fold that flat. This is kind of like unfolding a box. I'll do the same thing with this side. Axis of rotation right along the bottom. And we'll fold that flat. Same thing here. Axis of rotation along the bottom. And we'll fold that flat. And we'll get to our last point here. And I'll fold that flat. So now, if I were to look at this in the top view, I have the outlines of each of the sides that I need with all the steps that I need. Okay? There's only one tricky part to this, and that is that when I go to glue this together, I have to compensate for the fact that there is thickness of these stepping sides. So on two opposing sides, and it doesn't matter whether it's the short pieces or the long pieces, I have to subtract off whatever the thickness of the cardboard is. Well, I know the thickness of the cardboard is 31.25 feet because that's what I used as all my contour intervals. You could do this after you scaled it down and went to go cut it and do it at 5/32 instead of at 31.250 feet. It doesn't really matter. But I'm going to do it here. And what I'll do is I'll start with a line. I'm going to come over, I hope, by 31.250 feet to right there. I'll do the same thing, 31.250 feet right there. And I'll use those two lines that I just created, there and there, as trims. And I'll get rid of that piece and that piece. And then I'll join these back together. Yeah, they're all joined. Okay, so you can now see that there's a gap. Instead of these meeting at the corner, there's a gap. That's to compensate for the thickness of the material. Okay? Sometimes you'll forget about it and you won't do it. Remember that when you're actually building the model, you'll have a knife in your hand, and if you need to take off 5/32 of an inch, you can do it by hand. I know that's it's a touchy subject, but it's possible to do it by hand. So let me go ahead and do that on the opposite. Remember, they have to be the opposite side. So I did it on the long side. I'll do it again on this long side. I'm going to go over 31.250 feet. And right over here at 31.250 feet. And we'll trim using these 2 points. That and that. I'm going to select everything and then join. And now I have this piece and this piece, both at the correct length. Okay? So now I have those pieces, which is great. I have all four sides. Now I need the contours themselves. Okay? So let's go ahead and turn back on those topo lines that are there. The problem here is that the topo lines are in 3 dimensions right now. And so I need those to get down to being flat. So what I'm going to do is I'm going to project those onto a surface. And I can actually, in the interest of not distracting things, let me move these. I'm done with the sides altogether. So let me go ahead and just move these away. Let's move them up here for later. And so now what I'll do is I'll create a surface, just a rectangle corner-to-corner plane, that's larger than all of my contours. And once again, in the top view, I'll do a project to get all of these contours flat. So we did this back in exercise 211 and then exported to CAD, which is kind of the precursor to the direction that we're going. So I'll go up to curve from objects, project, or I'll go ahead and type project. It's going to say select curves to project. It'll be these curves. And I want to project them onto this surface. And so I can go ahead and press enter there. And I now have a flat set of curves on that particular surface. Now, so that I don't get confused, right, I'm going to go ahead and turn back off my topo lines. And now I have just, I can get rid of the surface. Now I have just the set of actual contours. Okay? I'm also going to need a rectangle that goes around all of these so that I have an outside border when I go to cut it out. So I'll go ahead and add a rectangle. This is not a plane, it's just a regular rectangle that goes all the way to the edges like that. So in the top view, I now have the contours and I have a rectangle that goes all the way around, kind of binding them. So one of the ways that this whole thing works as a strategy is that we actually stack up the cardboard. So you see that it's hollow on the inside and hollow on the outside. If I were to just cut this out, I'd have individual pieces of cardboard, but I wouldn't have any surfaces to glue them on. So instead, I'm going to make 2 copies of the same contours. So I'll take this and I'll copy. Oops, can't type. Transform, copy, and I'll create a second copy of the exact same topos. Now what I'm going to do is I'll start with the first one, and I'll start at the very bottom-most edge, and I'm going to alternate as I go up and select. So let's say I have this. I'll go to the next contour there. Now this gets it. Well, let me start at the top. Right? Let me start here. This is a little easier. We'll start there. I'll skip to the next contour. I'll skip to the next contour, etc. And I'll work my way down the model like this. Now, in this particular example, it gets a little tricky because I have some ups and downs in the lower flats. And so I'm going to have to pay attention to kind of what's happening, and I may have to reference these side steps to make sure that I'm getting the correct definition here. So if I skip, I would include this one, and I would include this one. Now, I missed a few in this hill, so we have to go back up the hill. It's that one and that one. And then I have to look carefully at the bottom so that I can make sure, remember this was virtually flat, and so I have to make sure that I'm selecting all the curves that are on the same edge. So this particular curve here would be the curve that ends right there. That would be at the same level as this curve. So I'm looking in this view at my, here, let me flip this. No, it's probably easiest to see it upside down. Right? That curve is right there. It meets at that point. This curve meets at that point. That curve meets it over to here. Right? So I'm going to select this one as well. So it takes a little bit of mental game playing to see which direction. If you have a surface like this that doesn't kind of go back on itself, it's a lot easier to figure out which curves to select. But I can help you through it if you're struggling a little bit. OK, so now I'm going to go ahead and create a new set of layers. So we'll do a new layer, and I'm going to call this the cut layer. And I'm going to change these objects to be on that cut layer. And I'm going to change the cut layer to have a color of red. And this is important to do because we need this for the laser cutter. It's going to recognize this as an actual set of lines that we can cut. This one? Thank you. So let me change it to be on the cut layer. And actually, let me go ahead and create a layer called laser cut. If I can type. And we'll put the cut layer underneath the laser cut layer. And then we'll also add another layer underneath for engrave. So the laser cutter has a couple different functions. And I'm guessing that a lot of you have already cut things because you've been through 121 and you've kind of experienced this before. But it doesn't hurt to kind of refresh and remind you. The laser cutter, any line that is red in pure red will get cut. And any line that is blue, pure blue, will get engraved. So I have all of the red lines established here, but I'd like all the lines that are currently white to also be selected, and I'm going to make those blue. And that will leave me a little tiny engrave line to reference when I'm gluing my model together. So let me go ahead and change object layer. There we go. And so now I have the blue lines and the red lines, and the border that goes all the way around should be cut out. So we'll go ahead and change that as well. So this side is ready to be cut. When I move to the second, remember I said I needed 2 so that I had something to glue on, I have to do the opposite. So if I started with red here, I'm going to start with blue on this set. So that'll be blue. So the first ones that I'll go through will all be blue. So I'll hold down Control, or excuse me, Shift, and I'll select every other line. There. And there. OK. So I've selected every other line. These are all going to go on the engrave layer. So I'll change object layer. There they are. And the opposite are going to end up on the red layer. So we'll do this, and we'll work our way up here. All right, I've got them all. We're going to put those on the cut layer. And the border is also going to be cut out on both of them, so we're going to put it into the cut layer. Okay, so now if we look carefully at these, the opposites, so this circle is red, that circle is blue. They should just be opposite each other. And what will happen once you cut it out is you have two versions of these topo lines, and you'll take the first one from one pile, and you'll take the second one from the next pile, and it's kind of like shuffling a deck of cards. You take one from each, and they'll glue together, and they'll stack up to make a really, really nice final model. Now, if your terrain is very steep, okay, and you're trying to accommodate, a really steep piece of terrain, the thicknesses between these might start to get too small. So you maybe have a 1/16 of an inch. Well, if you engrave in between a 1/16 of an inch, that would be a 32nd of an inch, and the ability for you to actually glue one piece to the next is going to be very challenging. So in the scope of this class, probably the easiest solution is to pick a piece of terrain that's not so steep. But let's say you actually had a project that you had to do a topo, and it was really steep. Okay? If that was the case, you could do more than 2 sheets and thicken up each of the pieces. So if I did, say, 4 sheets and 4 versions of the cut, I'd have a red line, a blue line to engrave, and then I'd have skip 2 or 3 contours, and then depending on how many versions I had, and the glue pieces would be larger as they stacked up.
When do you find that out?
Well, I would know here, I can kind of tell that these don't get narrower than a 1/16 of an inch. If this is 11 inches, or this is 17 inches by 11 inches, the steps here are not thick enough. They'll be plenty thick. Right? If you had a density that was much skinnier, where you have these lines really close together, that would be challenging. And I have some over in my office much steeper than, say, this piece that I keep showing you, that you can see. You can get them fairly close together. But if it starts to get in the less than 1/8 of an inch, you're going to have a really hard time gluing them together. Okay, so I have these 2 versions that are going to be ready to cut out. I have the sides. Those need to go on a layer to cut out, so I'll change their layer to be on a cutout layer. And so the last piece of the puzzle is that I really need to get these files ready to go cut. And if you're going to go cut on our particular laser cutters, the size of the bed is 12 inches by 24 inches. And so I'm going to go ahead and draw a rectangle, and that rectangle should be 12 inches by 24 inches. At this scale, that would be 4,800 feet by 2,400 feet. So I can say at 4,800 feet, 2,400 feet. And that represents the size of the laser cutter bed. That's the maximum size piece of cardboard that I can cut. So I'm going to take as many of these 12 by 24 sheets as I need. Let me copy a few more. I know I'm at least going to need 3. I'll probably need 4. And then I'm going to arrange these objects onto these sheets. So we can start with this first piece, and I'll move it on. A lot of times turning off ortho is a good idea here, and potentially disabling your snaps is a good idea. I want to make sure that my border isn't right on the 12 by 24. The laser cutter doesn't cut all the way to the edge. It's a little bit less. It has margins. So I just want to make sure that I have it placed kind of nicely in my sheet. There's my first one. Here's my second one. I'll move this one as well. There. I'll take this piece and I'll move it there. Take this piece and I'll move it. Looks like I'll be able to get away with 3 sheets, I think. And we can take this piece and we can move it there. Now notice I did not flip any of the pieces. You're okay to rotate them, you just don't want to flip them because you want the direction of the cardboard to stay consistent. So I'll move this one as well, and I'll put it right there. So it turns out I didn't need this last one. I only needed 3 sheets. So I've laid those out. I have them ready to cut. Now the very last piece of this puzzle, and actually you don't have to do it as the last step, but these are still in full scale. And so I could export these as an AutoCAD file, and when I went to actually do the laser cutting, I could apply the scale. To me, it's easier if it's just in the scale that you finally want to cut it in. So I'm going to take this overall set of pieces, and I'm going to do a regular scale to it. So I'll go to Transform, Scale. It's going to be a scale 3D, or just type scale. And I know that, for example, let me turn on my snaps here. I know that this edge from there to there is 24 inches. So I'll do a scale from here to here, and I'll type in the new value, which is 24 inches, and I'll hit enter. Now it gets really, really tiny because we just went from 4,800 feet to 24 inches, 2 feet. So I'm going to do zoom and then S for selected because it's still selected, and now I can see it. Okay? So from here, it's just a matter of going to File, Export Selected, and I'm going to save this not as a Rhino file, but as an AutoCAD DWG, an AutoCAD drawing file. I'm going to make sure it goes into my Exercise 213 folder, and I'll call this 213. And I'll go ahead and click on Save. The export, the DWG 2004 polylines would be the best option for you. I'll go ahead and say OK. And I've now written my AutoCAD file to be able to go next door and laser cut. Part of the reason that I've given you so much emphasis in class is so that you can have this file ready. Okay? Today's, I'm asking you to post this DWG file to the course website. So this is what you have to have as proof of working today. If you don't finish it, it's okay, but you have to post the DWG file. So there isn't going to be some nice featured image or anything. It's just this DWG file. You do, however, have to make a separate post as part of your assignment 202. So if you feel like you're all ready to go and this is your digital file to go cut for assignment 202, make a separate post for it so that I can give you credit for that digital file. If you have no clue what I'm talking about, go back and read assignment 202 because this is one of the requirements of assignment 202. Because not only are you going to hand me this after spring break or a week after spring break, you also have to, before that, there's some due date, I don't remember what day it is, you have to post the AutoCAD file to the course website. So it's a two-part thing. Okay, what? April 4th. You have to do it by April 4th. Okay, so I have this as an AutoCAD file. There's one last thing that you have to do in AutoCAD that you can't do in Rhino. The lab techs can help you do this over there, but if you feel comfortable doing it, I want to at least show it to you. If I go and I open that file, and since it's an AutoCAD file, if I double-click on the file itself, it will open in AutoCAD. This comes up because it was written by Rhino, not AutoCAD itself. And you just say Continue. And we see there's my file already set up for me to go ahead and cut in Rhino. I have this all ready for me, but I need to go to this button for Layer Properties, where we see my cut and my engrave layer. They're red and blue. The colors are correct, but the line weight is not correct. And so for the laser cutter to see this and to cut it correctly, we have to switch from default to 0.00. And so on any and every layer that's available here, you may have other layers that come in with you. You may not. I'm going to go ahead and click on it and say 0.00. So it's under line weight, 0.00. 0.00, and 0.00. When that's done, I can just save my file, and I can close AutoCAD, and I can walk over to the laser cutter and bring it on my flash drive, and that'll be ready to cut. Okay? There are lab technicians that will work. There's usually a sign-up sheet on the door. They can help you if you've never cut a file over there before. You'll have to buy your own cardboard. You'll have to provide your own glue to glue this together. I don't think either one of those is particularly challenging. It would be helpful if you also had an X-Acto blade of some kind, because you have to do a few modifications to the actual file or the pieces that have been cut once you start gluing it together. So I have this file ready. I will laser cut it for next class, and I'll do a live demonstration of kind of how it all glues together, give you some tips about that side of things as well. I know that this is a very long assignment because I didn't want to have it due right after spring break. So don't forget about it and start working on it. After today, you actually should have all the skills that you need to be able to cut this out and glue it together. Okay? I'm always a little hesitant to accept the assignment ahead of time if you glued the model together, say, by next Monday. But for this, because they're such a pain to haul around and whatever, if you want to give it to me early, that's okay. I'll put it in my office and then grade them all at once. Okay? That should have covered the whole thing, I hope. All right? So that's how to build a topo model.